Necessary condition. A necessary condition is a given piece of information that must be known and applied to solve the problem. Quote, to find two numbers such that their sum and product are given numbers. Necessary condition. The square of the half the sum must exceed the product by a square number. This is of the nature of a formula. Given sum 20, given product 96, 2x the difference of the required numbers, etc. Exegetics, solving the problem, page 31. Zeitetics, setting up the problem, page 31. Logistic, the calculation of solutions to problems. Homogeneous terms, this is the latter magnitude thing. Terms can only be compared to other homogeneous terms. Method according to Descartes. Deduction and inference from other certain facts. Quote, hence we are now in position to raise the question as to why we have, besides intuition, knowing by deduction, by which we understand all necessary inference from other facts, which are known with certainty. Universal mathematics according to Descartes. Mathematics that include all the kinds of mathematics. Quote, but as I consider the matter carefully, it will gradually come to light that all those matters only were referred to mathematics in which order and measurement are investigated, and that it makes no difference whether it be in numbers, figures, star sounds, or any other object that the question of measurement arises. I saw consequently that there must be some general science to explain the element as a whole, which gives rise to problems about order and measurement, restricted as there are no special subject matter. This, I perceived, was called universal mathematics. Not a far-fetched designation, but one of a long standing, which has passed into current use, because in this science is contained everything on account of which the others are called parts of mathematics. Page 61. Abstraction according to Reid. Abstraction is identifying attributes about a subject. Quote, analyzing a subject to its known attributes and giving to each attribute a name signifying that attribute and nothing more. Page 71. Nominalist. A nominalist is someone who believes that the only universal things are words and names. Quote, that there is nothing universal but words or names. 74. Newton's moment is a quantity that is basically an infinitesimal, so small that it barely exists, or more technically, it is a just now nascent beginning of a finite magnitude. Finite particles are not moments, but the very quantities generated from the moments. They must be understood to be the just now nascent beginnings of finite magnitudes. Page 108. Function. The term originally indicated the powers of a single quantity. Now, though, the term function refers to any quantity that depends in any way on another quantity. Binomial expansion. A way by which to convert one fraction into an infinite series of other somewhat simpler fractions. The pyramid that helps explain this is it's the 1, 1, 2, 3 thing that Samuel always draws, and so on. Page 105. Ultimately equal. Quantities and their ratios, which in any finite time can tend, and will, or have become so close to one another that their difference is less than any given quantity, become ultimately equal. Once the process stops, anything left over is smaller than any possibly given circle. So, for all practical purposes, it's equal. Page 101. Newton uses this in Lemma 1 and 2. Race course. One of Zeno's paradoxes, the dichotomy, where the half must be reached before the end, but the world is continuous and motion does not exist. Page 87. Leibniz differential calculus, or method of differences. It's a kind of mathematics that allows one to consider two different quantities that are only different from one another by an infinitely small amount. According to Berkeley, its base principles are not based on obviousness and were not demonstrated. Quote, the first geometricians who employed differential calculus, Leibniz, the Bernoullis, based it on the consideration of infinitely small quantities of different orders, and on the assumption that one can regard and treat as equal the quantities which only differ from each other by infinitely small quantities. They did not occupy themselves with demonstrating this principle. It showed that the differences which one supposes infinitely small must be absolutely null, and that their ratios, the only quantities which really enter the calculation, are none other than the limits of the ratios of finite differences, or they are undefined. But it is necessary to acknowledge that this idea, though justified in itself, is not clear enough to serve as a basis for science, whose certainty must be founded on obviousness, especially if it is introduced at the beginning. Page 102. Evanescent quantity is an infinitesimal that is barely still more than zero, or more technically, evanescent describes that which is going out of existence. Nascent describes something which is just coming into existence, and evanescent describes that which is going out of existence. Page 103. Limit. When the values successively attributed to the same variable approach a fixed value indefinitely in such a way as to end up by differing from it as little as one could wish, this last value is called the limit of all the others. Page 135. Lagrange. He did the theory of analytic functions. He did not like Newton and felt his rules were inconsistent. Page 103 to 131 to 133. Derivative is the slope of the tangent to the curve, or the rise over the run. 145. Continuity, that which has no breaks. Page 9. Dedekind's cut, the separation into two classes, what a number is and produces. Page 13.